All right, welcome to another lesson in geometry. And today we're going to talk a little bit more about proofs and how we do geometry proofs with parallel lines in them. And what we're going to really talk about today is we've been giving you the fact that, hey, these lines are parallel. What does that mean? Today we're going to talk about, well, what does it mean if we don't tell you that they're parallel, but want you to prove it to us? And so that's kind of where we're headed today. So here on this left-hand side, what we have is all of the reasons that you have for what you know when lines are parallel. If lines are parallel, then alternate interior angles are congruent. What do those look like again? Those are when you have an alternate interior, it's when you got an angle inside and you flip over the transversal and slide down. Those are your alternate interiors. What else we had for parallelism? If lines are parallel, then corresponding angles are congruent. And what I always say about corresponding angles are those are the ones that are basically like in the same position. So here's the top right, here's the top right. There's your corresponding angles. And last but not least, if lines are parallel, then same side interior angles are supplementary. What are same side interiors? They're exactly what they sound like. If I have a pair of parallel lines, same side interiors are on the same side of the transversal and squish between the parallel lines. So if I knew that these lines were parallel and these lines were parallel and these lines were parallel, all those angles would be congruent or supplementary. Okay, that's if we know the lines are parallel. On this other side now, we make the distinction that if I look at some lines and I notice that between those lines alternate interiors are congruent, then I can say the lines are parallel. In other words, if I had a picture that looked like this, and I wasn't sure whether these are parallel, like one maybe, I'm just not sure yet. And I looked and I said, okay, this angle right here is congruent to that angle right there. If I knew it, like I saw the measure, I would say, oh, well, those angles are congruent and they're alternate interiors. That means those lines must be parallel. So I can say that is now true. That's what these converses are all about. A converse is when you take an if-then statement and reverse it. So if you have alternate interiors that are congruent, then the lines are parallel. If you notice some corresponding angles that happen to be congruent, then the lines are parallel. And if you notice some same side interiors that add to 180, then the lines are parallel as well. So we're reversing it. Now, how does that look when it comes to a proof? Well, if I have some kind of a proof or something that we ask you to justify, and in asking you to justify it, we say, hey, we're telling you these lines are parallel, give us more information, that's when you're going to use the left. The left column are reasons that you use when you are given that the lines are parallel. However, we're going to use those guys on the right, this column, if we use these reasons when you need to prove that I have parallel lines. So left column is when in the givens it says, hey, yo, you, these are parallel. Right column, you use those reasons when nobody's told you about parallelism, but you think it exists. Okay, so how does that look? Well, let's see. So if I come down here, it says in the figure at the right, the measure of angle 1 is given to be equal to the measure of angle 8. I now want you to prove, whoops, look at that, I found a typo. I want you to prove that L is parallel to M. Okay? L is parallel to M. In the notes you get, that should probably be corrected, but on my virtual copy it was not. My apologies. So if 1 is equal to 8, prove that L is equal to M. Okay, well, when you write out a proof, our first statement is always to write down the givens, just so we kind of set up some dominoes here that fall as my proof goes through. So 1 is equal to 8, that was given to me. Now, whether these lines are parallel or not, vertical angles are always equal. So I'm going to come over here and say, all right, 1 and 4 have to be equal because they're vertical angles. How do I write that in a proof? Like this. Measure of angle 1 equals the measure of angle 4 because vertical angles are congruent. And then I look and notice, wait a minute, if I look at my picture, the arc is on the 1 and the 4, and the same arc is on the 4 and the 8. So now I've realized, hey, wait a second, the measure of angle 4 now looks equal to the measure of angle 8. Why is that? It's because of substitution. If 1 equals 8 and 1 equals 4, then 4 equals 8. Okay? So now we have the measure of angle 1 equals the measure of angle 8 by the substitution property. And what kind of angles are 4 and 8? What kind of angles are 4 and 8? They are corresponding angles. And not only are they corresponding, but they're corresponding angles that so happen to be equal. Therefore, I can say, hey, look at that. I have corresponding angles that are equal. Therefore, I know that L is parallel to M, because if corresponding angles are equal, then the lines are parallel. And that is how you use that reverse, that converse statement. I wasn't given that they were parallel. They wanted me to show that. I did that by getting to a point where I recognized some congruent angles that had a name. Okay? Now, one of the things we just noticed is that if 1 equals 8, the lines are parallel. Oops, pardon me, that wasn't what I meant to do. 1 and 8 actually have a different name. 1 and 8 are outside, right? 1 and 8 are outside like this, and they are on alternate sides of the transversal. They actually get a special name that we're going to fill in up here, and that special name is the following. If alternate exterior angles. Oh, I made a mistake. Sorry, guys. Sorry. Sorry, I put that in the wrong column. Let's try again. I meant to write, if lines are parallel, then alternate exterior angles are congruent. Sorry about that. On the left, it was the if parallels. If lines are parallel, then alternate exterior angles are congruent. And on the right, if alternate exterior angles are congruent, then lines are parallel. And this is one new type of angle you can use now. Alternate interiors, alternate exteriors, and corresponding angles are all congruent. Same side interiors are supplementary. So no rule you can use. My apologies for the erasure. All right, last one, and then I'm done here. So if we jump down here to this last proof, in this proof, I'm given that L is parallel to M. So if you're given that, then you can use that parallelism to talk about congruencies, and that's what we're going to do now. So I'm given that these are parallel, and they want me to prove that 1 and 7 add to 180. Okay, so my given becomes the first statement and reason in my proof. Next, I want to use something about 1 and 7 that might be helpful. I'm going to use, let's see, that 1 and 7 need to add to 180. Well, I don't really know why that's true, but I know 1 and 3 add to 180, right? Because they're what? What are they? Linear pairs. Who said that? It was me. Those are linear pairs. The measure of angle 1 plus the measure of angle 3 equals 180. Because linear pairs are supplementary. Okay, that's cool. And then 3, how is that helpful? Well, if only I could swap the 3 with a 7. Could I swap the 3 with a 7? Well, what's the relationship between 3 and 7? What's the relationship between 3 and 7? They're corresponding. Who said that? It was me again. They're corresponding. So the measure of angle 3 is equal to the measure of angle 7. because if lines are parallel, then corresponding angles are equal. And now, if 3 equals 7, that means 7 can replace 3. So now I can rewrite step 2 with a 7 instead of a 3. So if 1 plus 3 equals 180, now I get to say instead 1 plus 7 is 180. And that is the substitution property. Okay, so there's one proof where you're proving lines parallel, one proof where you're given that lines are parallel, and as always, we're going to end with a joke. What did Cinderella wear to Ariel's wedding? What did Cinderella wear to Ariel's wedding? Her glass flippers. Glass flippers, everyone. All right, enjoy your day, evening, morning, whatever time it happens to be when you're watching this, and happy geometry-ing.